My background is I was a captain of large oil tankers for many years and was managing risks in Singapore for a large fleet of oil tankers. And then I came back and we started all this. So I understand oil, I understand the seas, I understand the waves. So that's where I come from. We have carried out marine environment impact assessment of a coastal nuclear power plant before this NABED business came in. We have wide exposure. Then we got into technology development. We have developed technologies to harness ocean energy from the ocean wave, trapping silt, robots to clean crude oil tank, a lot of that right here in India, in Bangalore. Time permitting, I'll tell you about that. But meanwhile, another aspect of it is I am the India Council member on the non-executive council of International Spill Control Organization. That's an organization with members from about 45 countries. It's a think tank, and that does a lot of wonderful job. They have debated heavily on sinking oils. The oil that we discuss about is a floating oil. It's a very important subject, but there are some other pollutants that go down, and often we don't worry about that. So this organization has been debating about that. One more very important job this organization has done is a standard spill response assistance form they have created, almost equivalent of Lloyd's open form, where the vessel help each other for salvage. Similarly, a standard form, because we are dealing across 100 countries, and you need a standard format so that people can communicate with each other. There was a drill I remember we have done, AlphaMERS was one company which had participated in North Korea along with the Coast Guard, communication exercise with organizations across the world. And when they ask for assistance, and by the time the response comes, the format, the forms each country uses, what they mean, what it looks like, what people understand, it's a little complex. It takes hours, 12 hours, 14 hours, time zones, language, the expression, the interface. It's quite complex. It's very interesting to understand that in case of a real big spill where international cooperation is required, what are the challenges? Now, I'd like to show you a 2-minute video to show you some of the work that we have done, and then share with you my views on this sector, what is the current status, and what are the challenges, what we need to do. So, can you kindly play that DC Sekhar skimmer? Sorry, DC Sekhar. Yeah. There may be some volume there. Thank you. All that you have seen was designed, conceptualized, made in Bangalore, very much in India. I'd like to now go into some of the capabilities, challenges in spill response that we have. One of the wish list, what we like to do is the speed of containment. When Bombay, there was an oil spill, it was coming out from an oil pipe of 6 inches dia, and that oil which came out coated miles of the coast. That's what can happen. Oil spreads so much that can coat miles of the coast. So one of the first priority is containment. There are places like Gulf of Kutch, where the currents are so strong, your conventional booms cannot hold out in that speed because the relative speed of water is so high. The key word is the relative speed. So there are other places like maybe Chennai harbor, there's not much currents, but there you would like to sweep, you like to go through the water and sweep faster. So one of the latest generation of this equipment is called integrated skimming system. That is a boom and the skimmer together. It's interesting how human mind thinks differently. Each human mind thinks very differently. There are some designs in the world, maybe I think 4 or 5, and we also have a design which is totally different from these designs. We are developing that, and the wish list is in the years to come, in the months and years to come, we are able to go at 2 knots and 3 knots and sweep faster with these systems. Rivers pose a challenge. Once again, it's a situation is somewhat similar. The relative speed of anything you deploy in flowing waters is a challenge because the hanging fabric cannot stop the flow of water. And the fabric is going to lift, and when the fabric lifts, along with that, the oil can escape. That remains a challenge, similar challenge. So, in fact, this trash barrier that you saw for arresting floating marine debris, this we had designed 7 years back. I remember I was watching on the television the oil spill in Sundarbans. There was a tanker which broke up and some furnace oil escaped in Sundarbans river, and the water was carrying the oil away. And with a lot of trash, so the skimmers couldn't work over there. So at that time, we decided we should make something that allows the water to go past along with the oil on the surface, but stops only all the twigs, branches, marine biota and that. We made that. So far, no oil company or port has asked us for that particular product, but it has become very popular as a river cleanup barrier. In so many countries, we get calls from right from Greece to Nepal to all over the place for the technology, because it's one of the 3 successful technologies in the world today in terms of sheer volume. One more big challenge is viscous oils. The furnace oil that the ships burn, smaller ships burn diesel oil, the bigger ones, they burn furnace oil. And the furnace oil, the pour point, many of you might know, pour point of that will be usually higher. That means when it comes to the ambient temperature, they will become like grease, thick, like paste. And our regular pumps cannot handle that. So this is a risk we have been living with, and I don't know why, but we are living with this risk. And you may not have oil tankers coming to a port, but you will definitely have bigger size cargo ships coming which have got furnace oil in its tanks. So when that leaks out, what's our answer? We had made one skimmer which had a progressive cavity pump, one kind of pump that is actually used in pharmaceutical industry. And it was kept in one corner of our warehouse. We said someday this will be required when there is a furnace oil spill, and the NO spill typically was one of that. So we pulled that out after maybe 2 years lying in a corner, and then we put it to use, and after one day it was overworked, it got jammed. But you don't have other answers to that furnace oil spill. You need progressive cavity pumps or other pumps that can handle the paste. That's the risk we are living with. Underwater spills, as of now, there is really no answer except you can do a recce maybe with ROVs. How big is a patch? But as of today, you don't have any answer how you're going to remedy that, how you're going to collect that. Nurdles, it's not oil, but when it behaves like oil, And we had a vessel near Sri Lanka that spilt a lot of nurdle that all came on the Sri Lankan coast. You need pumps that has got a big solid tolerance, so along with the flow it can perhaps pick up a lot of it. We have still not started working on nurdles. This is something we need to anticipate ahead of time. Like we thought about that furnace oil spill, we need to think about it and make some equipment now. Often this is dictated by the revenue model, because a port or an oil company will procure what is being mandated. Some may have the vision to go more than that, but that is the minimum. So if it is not part of the mandatory list, nobody is supporting you with an order, because their finance department is going to ask them, okay, why, who said you need this kind of thing? I'd like to mention about the traffic on our coast. We are one of the biggest importers of oil. Besides that, there's a lot of international shipping passing on the west coast. The shipping that comes from the Persian Gulf, that comes closer to Goa, Karwar coast, and it is hugging the coast along about 10 miles away. And it goes beyond Trivandrum and then goes towards Sri Lankan coast. We have been discussing about oil field spills, but oil field, what happens, even the biggest oil field spill, that is Deepwater Horizon, it happened over a period of almost 3 months plus. It gives you a little reaction time to mobilize resources, to collect resources from around the world. And it's progressively happening. Even the human mind comes up with the solutions of top hat, and there were some various things that was actually designed at that time. But what happens when a ship breaks up? You had many cases like Prestige, you have Lord Natuna Sea in Singapore. When the vessel breaks up, suddenly 5,000 tons of oil is released close to a coast. And no country in the world, not even US, which is one of the most prepared countries, spends so much on preparation, can handle a sudden onslaught of so many thousands of tons if it comes towards your coast. That's the reality. Of course, the ship's design has become a little better. It's become double hull tankers. So when an accident becomes a polluting accident, the threshold is slightly increased. By the way, do you people, have you heard the most irreversible form of pollution? What is that? Any idea? It is not an oil spill. It is the ballast water exchange. Is considered the most irreversible form of pollution, because you are getting ballast water, few thousand tons, 10, 20, 30,000, 50,000 tons of ballast from maybe Australia to India or to the Persian Gulf, and you pump out that ballast water along with all the microorganisms that come with that water. So you're putting foreign microorganism species into the local water, and that changes the ecology of that water. That's considered the most irreversible form. Oil spill, at some point of time, the effect is negated. We are such a big consumer of oil, and we have such a lot of oil activities. I fully agree with what Mr. Sanjay said. There is no reason why we should not have tier 3 spill response capability in India. A typical boom reel, as we call the boom that is deployed, 200 meters of that along with the steel reel on which it is, will be about 4 tons. You can't send that in aircrafts. You have to bring it on a ship. Once you decide to bring it on a ship, then after that the shipping times, all those things. Even if you forget the customs time, still there's it takes up a lot of time to bring from Singapore or Bahrain. So there's no reason why we should not have these facilities right here in India, within truckable distance. One of the things about disaster management resources is, it's not an automatic choice for people to invest because it doesn't bring you revenue. It's a necessity, it's a risk management. So if you have 20 facilities, between the 20 facilities, they would like to have 2 sets or 3 sets and have a hub and spoke model, so that the moment it is required, these resources are going to one side. We need to work on that. We have given a proposal as well, and we are not big like Lamore, but we have suggested a model how a couple of players can come together and put the resources together. It's not as expensive as it is made out to be, but the government has to clearly define what is the capability it is looking for, how much time you have to get this additional support, and what should that support be able to do. Then rest of the things can be structured around that, but it's very much possible here right in India. You might be interested in knowing that in US, every ship that comes in has to pay a certain amount of money, not too much, to one of those oil spill response companies. OSROs, they are called oil spill response organizations, and they come and put up the resources while they are operating in the port. So that OSRO is getting some revenue, trickle of revenue, he is able to maintain his resources, and you are getting a certain protection on the ship. That revenue modeling is very important part. Earlier on, I remember when I was talking about saying that we can do this, but they said, okay, when there is a spill, somebody will call you. It doesn't work like that, because I have to maintain the resources, pay the people, and we should have a trickle of revenue coming, then we can maintain the resources. We could be very cost efficient, but still we need some fund that has to trickle in. The same thing has been adopted by China as well. It hasn't happened in India as of now. Going away from the topic for a very quick one, what we have developed over here in Bangalore is harnessing ocean energy. We have tested our prototype at IIT Madras and quite happy with that, and we have designed a wave powered boat, not prototype the wave powered boat, but we'll be doing that shortly. It is definitely possible. It's one of our old theories that the human intellect is very equitably distributed around the world, better than diamond and oil. So we are a country of 1.4 billion people, and we can do a lot. And I sincerely hope all of you young people out there, I was more ordinary guy than you when I was in that stage. So if you people, I'm not saying you should get into entrepreneurship, that's purely your decision. But if you decide to do something, you have a lot of capability within you which you don't know today. You have to have the determination. We developed that robots that to clean the crude oil tanks. Because it's for crude oil tank, it has to be fit for ATEX Zone 0 or ICX Zone 0 standard. That's a very high stringent safety standard. And that's the reason it is totally powered and controlled by hydraulics, except for a camera which is already pre-approved, ATEX Zone 0. Yeah. Coming to my closing line is again a wish list that what is it that we need to do going ahead. One is very light booms. Today we're talking of boom reels with 4 tons. There is somebody in Europe who has made a boom that is held inside a suitcase. Of course, it's not heavy duty. Of course, it's not very long. But he is going and taking a flight with that suitcase, or 2 of them. And the response time improves tremendously. That is, whoever has done that has done a very good job. The other thing I wanted to mention is, when you see on the west coast, such a lot of traffic is going past the coast, it is like having a house in front of the highway. Once in a while, you open the door in the morning and there is a vessel, there is a truck which is turned over, some accident happens, you can't help it. It is going to happen. So it's ideal to open a shop or service center, whatever, to gain some revenue out of it, so that at one point of time you're happy that you're in front of a highway. Similarly, we need to develop our commercial services to the passing shipping on the coast, because this shipping is going to pass close to our coast. There is nothing really much you're able to do about it. It will be there. So take it as an opportunity. And for your information, there's a lot of this black tar balls that land up in this coast, Goa, Karwar and all that. One of the reasons, according to me, it hasn't been proved, but one of the reasons according to me is all these tankers which are going to the east, they change grades every time. That's a commercial thing. And when they change grades and when they come back with the washings, the Arabian Sea is the last place they can decant their tank. It is officially permitted as per MARPOL that you can decant the water inside your tank so that you can carry more cargo. So when you're decanting the tank, if you have 100 tons and 30 tons of oil and 100 tons of water, you may not be able to exactly stop at 100 tons. Somewhere there is an interface which can get mixed. So people might be walking the tight line, and you can stop that only if you invest in the kind of resources for monitoring like US. But also I'd like to mention, when the US catches a vessel, it takes the amount of penalty it charges, pays for all that. So that's a different model. So we need to also go back and look at these things. And the way powered boat that we designed has one of these purposes of going offshore with extended cruising ranges, remote controlled, without having to fall back for crew change and provisioning and all that. Thank you very much to all of you. Thank you.